Hey, Prob-Stats students, Mr. Mitchell here. We're going to start talking about variation, which is also known as spread in layman's terms. So let's get into it. All right. So there's three things that really are measuring the spread, the variation. We have range, standard deviation, variance. I would even include one other thing of IQR, which we will get to when we do box and whisker plots in the next section. So I would include that in variation spread. We're not going to talk about it except for right now. Okay, the range. Did this in 7th grade. You take your max value minus your min value. It's one of the easiest things to find. You're going to take your biggest minus your smallest. So finding the range here, when the numbers are in order, it's even easier, but you do need to locate your biggest and your smallest. So we got 18 minus 10, and our range is 8. So that would be our solution for that. Next is finding the standard deviation. Actually, we should talk about variance first, but we're going to just go straight to standard deviation. It's the measure of average variation of data entries from the mean. So the mean is in the middle. It's your average distance from the mean. Okay? Average distance from the center. Here's the formula. Looks kind of ugly. It's not the friendliest formula. We'll work our way through it, but there is a square root. You have to square root everything one time. You need to, this means sum. That's what that symbol means. You need to take each number minus the mean, square it, and then add all those up. And then you'll divide by n minus 1. So we're going to practice that. So we've got to calculate the mean first. And we already learned how to calculate the mean. So we calculate the mean. We can use our calculator to do that. Find the difference between each entry and the mean. These differences will add up to 0, so you don't add them. You find the differences. Then you square them. Then you add them up. So if you add them up before you square them, it's going to be 0 every time. And then you divide by n minus 1. And that gives you the variance. In terms of symbols, s squared is variance. S is standard deviation. If you find standard deviation by hand, you've already found the variance. And then you take the square root to find standard deviation. So again, there's the variance formula. Notice the difference. It's s squared, and there's no square root. So there's your difference between those. So let's go ahead and find variance and standard deviation of this. So what's the mean? So you'd add them all up and divide by 3. So 30 plus 26 plus 22 is 26. So that's our mean. If you don't believe me, add them up and divide by 3. Okay? So you take each number minus the mean, and you get 4. And then over here, you're going to square that. So then we do 26 minus 26, and you get 0. What's 0 squared? And that's 0. And then you take 22 minus 26. It's negative 4. Make sure when you square it, notice I put parentheses around this and this. 16. Okay? So what we'll do next is add those up. I'm going to do that on this page. 16 plus 0 plus 16 is 32. So the variance is 32 divided by, well, what's n? N is how many numbers we had. We had 3 numbers, so it's 3 minus 1, which is 2. So our variance is 16. Well, what's the standard deviation? Standard deviation is the square root of 16, which is 4. Our standard deviation is 4. So the average distance from our mean is 4. The average distance from 26 is 4. All right, go ahead and try this. I will pause. You have 5 numbers. Find the mean first, then subtract each number from the mean, and then you square them. And then you'll have to add all that up. If you keep things in a table, it does make it easier. So go ahead. I'm going to pause. You pause the video and give it a shot. Okay, so hopefully you've had a chance to try it. So our mean is 5. So we're going to take 4 minus 5, and we get negative 1. We're going to do 5 minus 5, and we're going to get 0. We're going to get 5 minus 5, and we're going to get 0. We're going to do 7 minus 5, and that's 2. And then we're going to do 4 minus 5, and that's negative 1. So now we need to square all of these. So what's negative 1 squared? 1. And then we're going to do 0 squared is 0. And we got 0 squared is 0. 2 squared is 4. And then negative 1 squared is 1. When you add these up, these should all be positive numbers. When you square a negative, it's positive. Make sure you type it in your calculator, right? Or just know that it's positive. So 1 plus 0 plus 0 plus 4 plus 1 is 6. Okay, so we already knew the mean was 5. Let's finish finding the variance. So we found our sum to be 6. And then we had, what, 5 data points? Minus 1 is 4. So our variance is 1.5. And then from there, you find the standard deviation by taking the square root of that, and you get 1.22. So that is how you calculate standard deviation and variance by hand. Okay? Here's another alternate formula. We're not going to really worry about that right now, what the sum of squares of x represent. That's what that means, SSX. This is another way you can do it. I wouldn't really worry about that right now. We'll get into some other notation later and some things like that. Okay? And again, with these things, we're going to let our calculator do the work for these types of things. Okay? So doing it the alternate method, this is what you would come up with. This is how you would approach it. And notice you still get the same standard deviation. Again, most of you are either going to use the calculator the whole way, or you're going to number crunch the way we did it the first method. Okay? Anything else we need to talk about is some other notation. Our capital N represents the population samples, or the population size. Notice our symbol. So we've had different symbols here. So X bar is the sample. And then this is the population mean. And the lowercase n means sample size. These are things that we do need to be aware of. If we're not, we're going to mess up. Just like we need to know people's names. Otherwise, if we give the wrong information to the wrong person, that's going to be a big problem. So we need to know what things represent what. Then we also have a population standard deviation. If you're calculating it by hand, everything's the same except you're dividing by capital N, not n minus 1. So standard deviation S equals the sample standard deviation. Another calculation that also determines variation is called the coefficient of variation. It's an easy calculation. You just need to take the standard deviation, divide by the mean, and then multiply by 100. I will give you this formula. You just need to know what each thing represents. CV does not represent Cumberland Valley. It's coefficient of variation. You need to know that. I'm going to write CV equals S over X bar times 100 on the board, or in a formula sheet or something. It's not going to say coefficient of variation. So you do need to know what the formula represents. So we're trying to see which one's more consistent. Okay. If we think of sports teams, some teams are more consistent than others. Some teams may always be good, but maybe they're never great, but they're never terrible. Then some teams may have one year where they're really, really good, and then they're terrible for a long time too. So a baseball team that comes to mind is the Florida Marlins. They've won the World Series several times, but then in other years they are the worst team in baseball. So just one of those. They're very inconsistent. They are not consistent. So here's some examples of when you would use variability, comparing it using CV. Sample of a newborn infants had a mean weight of 6.2 pounds and standard deviation of 1. A sample of 3-month-old children had a mean of 10.5 pounds, standard deviation of 1.5. Which are more variable? So let's do that calculation. So we're going to take our standard deviation and divide by our mean, and then we're going to times it by 100. So what is 1 divided by 6.2 times 100? And then what is also 1.5 divided by 10.5 times 100? What do they equal? Okay. So for the newborns, it was 0.16. And then for the 3-month-olds, it was 0.14. So the higher the CV, the more variable they are. The lower, the more consistent they are. So you actually want a lower CV. You want a lower CV. And if you think back to the example, the fact that the mean was smaller for the newborns and the standard deviation is still 1. It's pretty large. So there's more variation from 6 going up 1 and down 1 versus 10 going up. So there's more variation there. Okay. Last thing we're going to talk about is called Chebyshev's theorem. I know that's a mouthful to say. You do not have to worry about calculating all this. This is just where Chebyshev's theorem came from. Okay. Basically what you're doing, you're saying that all the data is within 75% of the data is within 2 standard deviations of the mean. So what this means, so if here's my mean, and you go up 1 standard deviation, 1 standard deviation, and then you go down 1 standard deviation, down 1 standard deviation. 75% falls in between here. That's what that means. An example of this, let's just say my mean were 10. So x bar 10, standard deviation is 2. So if I went up to 12, then 14, and down to 8 and 6, 75% of whatever we were talking about, I made the numbers up, fall between 6 and 14. That's what that means. 75% of all the data, all the numbers that we are talking about in this data set will fall in between there. Same idea. Again, you don't have to worry about the proof of this. You do need to know the 88.9% and 3 standard deviation. So if we stay with our same concept, if you add 3 standard deviations, and then you subtract 3 standard deviations. So we'll just take our numbers of 10 and 2 as a standard deviation. So you add up 2, 2, 2, and then you subtract down 2, 2, and 2. So that means that 88.9% of the data falls in between 4 and 16. That's what Chebyshev's theorem is. And then one last thing, if we start at our mean and go up 4 times, so we start at 10, you add 2, 2, 2, and 2, and then if you subtract down 2, 2, 2, and 2, between 2 and 18, 93.8% of the data or numbers or people in the study fall between those two numbers. So really the percentages, you have to have an idea of what they are. The one number is 75, if I go back, 75, 88.9, and 93.8. If you just know that it's 2 standard deviations, 3 standard deviations, and 4 standard deviations, you should be okay. The K number is 4, 3, and 2. That's kind of the idea. 2 standard deviations, 3 standard deviations, and 4. You should be okay to construct Chebyshev's theorem or use Chebyshev's theorem. Okay? So here's another example. I'm going to pause it so you can try it. See your answer here. So 77 minus 12, minus 6, minus 6. It's the same thing. You can double the standard deviation or you can just subtract it however many times you need to. It's the same thing. You do that, you get 65. So 77 minus 6 is 65. Then 77 plus 6 is 89. So there's your Chebyshev's 2 standard deviation interval. If you needed 3 standard deviation, you'd have to do another subtract 6, add 6. If you needed 4, you'd have to subtract it again and add it again. If you have any questions, let me know.